Well, good afternoon, everybody. It is Monday. Welcome to the KHOU 11 Weather Center. I'm Chief Meteorologist David Paul. This is your weather school lesson for the day. It is 2 o'clock, so I'm going to just wait a moment for everybody to come on in here and get logged on and open up the tab to watch the video. We're talking about the layers of the atmosphere today, which has always been a subject that fascinates me, especially when you look at planet Earth from, say, the view that the folks at the International Space Station have. This is what the planet Earth looks like from the ISS, from the International Space Station, as it orbits in outer space. Technically, it's actually in one of the layers of the atmosphere that we have defined as atmospheric, and I'm going to explain that here in just a moment as we talk about the different layers and the different heights and the different names and different things that happen as you go higher and higher up into the atmosphere. But one of the things that always strikes me as being so profound when I look at pictures of planet Earth from outer space is how thin, how incredibly thin and delicate looking, and it is delicate, our atmosphere is. This veil, thin veil, that surrounds planet Earth. It is incredibly thin, and you can see it from this angle. You see the planet, there's a cloud floating overhead, but if you look at the edge of planet Earth, that's it right there. Right there. That's our thin little layer of atmosphere. That's what encompasses and holds all life that we know of in the known universe that we're aware of. At the moment, we don't know that there's life anywhere else. That's it. It's kind of a humbling view when you look at it and think about it that way, but that's that thin little veil of atmosphere right there. That's what gives us, holds the oxygen that we breathe in and out and all the other things that go to make up life on Earth. And weather as well. So let's talk about the different layers of the atmosphere. Have you ever heard anybody mention the name or call the atmosphere the troposphere? Okay, so the troposphere, that's the bottom layer of the atmosphere, and it's written here on the graphic, and I've written it again so you can see it in big bold letters. Troposphere. That is the layer of atmosphere, the lowest layer, and that lowest layer is where all weather and all life as we know it exists. It's in that bottom layer, and it averages about 7 miles in depth. So from the surface up to about 7 miles, and it varies. It's not always a perfect 7 miles. Sometimes it's 3 or 4, sometimes it's up to 12. But that's it. That's all we've got. 7 miles of atmosphere where all weather and all life that we know of, exists. You get above that and it gets too thin to support life. There's not enough oxygen up there. So the troposphere, and what we've got drawn in here, this is Mount Everest. So Mount Everest is up there around 30,000 feet or so. And I don't know if you've ever watched specials on how people climb it, but they have to quite often wear oxygen masks so that they have enough oxygen to breathe. When you get that high, as you go higher up in this atmosphere, the amount of oxygen and the amount of particles gets thinner and thinner. And that is the main reason why this is going to be a little graph of temperature. So let's say at the surface we have an average temperature of about 60 degrees down at where we're walking around at the surface. As you go higher, the temperature drops and drops and drops, and as you get to the top of the troposphere, temperatures are average about 60 degrees below 0 Fahrenheit. So you go from 60 above Fahrenheit at the surface to 60 below Fahrenheit, and that's up there at about 60,000 feet. Okay, so what happens up there? Well, you can fly the big commercial jetliners up there at the top of the troposphere, and actually some of these can go as high as the bottom of the stratosphere. That's the next layer up, the stratosphere. There are still enough particles for the wing of an airplane to generate lift. So the planes that fly way high, the transcontinental flights, sometimes you'll see them leaving condensation trails way up there. They fly at the top of the troposphere at about 60,000 feet at about 7 miles or so, and they can get up into the bottom of the stratosphere. So the stratosphere is the next layer of the atmosphere as you go up. Here we go up. The stratosphere is interesting because instead of the temperature dropping as you get up to the top of it. Again, we're at about minus 60 degrees Fahrenheit here at the top of the troposphere. In the stratosphere, the temperature begins to warm, and it warms up. Now, it still stays below zero. The top of the stratosphere is at about 10 below zero or so. But what happens in the stratosphere is you get ozone production. This is where ozone is produced as light interacts with that layer in the sun. And that ozone creates these particles that warm up a little bit. So that's why you get a warming up here in the stratosphere. Temperatures warm back up. It is also because of that warming as you go higher in the stratosphere. If you have an atmosphere that is warmer as you go higher, it creates what's called stability. Nothing rises, so things sink in the stratosphere. There's also no water vapor up in here. There's no H2O. There's no H2O up here. No water. And that's why you have no clouds in the stratosphere. All the clouds that we know of occur in the troposphere. This is where you have H2O in its different forms, vapor, gas, and solid. So that's a little bit about the stratosphere. You've got ozone up here in the stratosphere. And we mention ozone because it is a chemical that helps protect life from ultraviolet rays of the sun. The atmosphere is doing some very important things to support life on Earth. One of the things is that it creates ozone in the stratosphere, and that helps to protect us from ultraviolet light. Okay, so that's your stratosphere. So then we go a little bit higher, and this is where things get interesting. Have you ever seen a meteor at night, a shooting star, streak of light across the sky at night? So now we're getting up into what's called the mesosphere. The mesosphere is where particles of the atmosphere are still present, but they're really beginning to get spaced out. It's getting very, very thin up here into the mesosphere. But there are enough particles so that if you've got a little sand grain of silicate floating through outer space, and it bumps into planet Earth and it gets caught in the gravity as it gets pulled toward planet Earth and it enters the mesosphere, there are enough particles around that those rapidly moving little grains of sand, those meteors, will burn up and become visible. When they become visible and streak across the sky, they're called meteors. That happens in the mesosphere. And I remember having a couple of tests on the layers of the atmosphere as a student, and I would always remember the question would always come up: what layer of the atmosphere do meteors occur? Well, meteors, mesosphere. Meteors, mesosphere. That's how I remembered it, and I always got that one right. So that's where meteors occur, mesosphere. And what's happening here, remember we talked about how in the stratosphere the temperature is warming? In the mesosphere, it begins to cool with height again, because at the bottom of the mesosphere, you have particles that are still fairly densely packed, but by the time you get to the top of the mesosphere, the particles are beginning to get further spaced out. There's just not much atmosphere, a little bit of nitrogen, helium, argon, a little bit of ozone. They're spread out. And when particles spread out, there's not enough of them to bump into each other, and they create less heat. So the temperature drops as you go through the mesosphere. Mesosphere is where the meteors occur. Okay, so I mentioned the atmosphere is getting thinner as you go up into the mesosphere. And it gets really thin as you enter the thermosphere, the next layer of the atmosphere, the thermosphere. The Kármán line. You ever heard of this? So it's at the bottom of the thermosphere, the Kármán line. What is that? That is the scientifically defined definition of where Earth's atmosphere kind of technically ends and you enter into the realm of outer space. It's that dashed line right there. And that occurs at we're about 60 miles up now, but it's still technically within the Earth's atmosphere. The Kármán line is actually a fascinating spot. We talked about the density of particles getting thinner, the particles of atmosphere getting thinner and thinner and thinner. There's more space in between them. So the Kármán line is as high as any aircraft can actually fly using aerodynamics, using their wings. You get above the Kármán line and there just aren't enough particles for a winged aircraft to function. Maybe you've seen, in movies, I remember there was back when they were testing the limits of aircraft and just beginning to think about going into outer space, they would see, well, how high can we fly a supersonic jet aircraft? And they found as they got up here to this one point, the plane would basically stop working and it would kind of float or it would begin to tumble because there's just not enough atmosphere for a wing to produce aerodynamic forces. That's the Kármán line. That's the definition of where the atmosphere ends, and now we're beginning to get into the realm of outer space. That happens in what's called the thermosphere. And I've written in here the ionosphere. Do you guys know what the ionosphere is? It's a layer in the thermosphere, and it produces this phenomenon. You know what that is? We're going to talk more about that in just a second. I know a lot of you know what that is. And Randy, if you're listening, if you have any questions or shout-outs, go ahead and give me a couple of them. Hi, Amani, third grade in pre-K. Nice to see you guys. Hey, Cameron, second grader Cameron. Nice to have you with us today.
And I do have a question from Preston.
Hey, Preston. Okay, Preston, what is Preston's question?
Preston's question is, why does the air become super thin the further you go up?
Oh, that's a great question. The basic answer to that is because of gravity. So gravity is holding all these layers of the atmosphere in place. That's what's holding it. And the closer you get to the surface of the planet, the more dense, the more tightly packed the particles are as they're all trying to get down to planet Earth. The mass of the Earth is creating gravity. So the mass of the planet Earth holds all this atmosphere down together. So as you get further down toward the surface of the planet, you'll get particles that are very, very tightly packed together. Take a deep breath. You're breathing in those particles that are dense enough, and the oxygen levels are dense enough so that your lungs can get the oxygen out and it supports life. The particles, what I'm drawing in here, are very densely packed together. The further out you get from the surface, there are fewer particles. So there's more space in between the particles, there are fewer of them, and there's so few that if you were to try to take a breath up here at 30 or 40,000 feet, there wouldn't be enough oxygen to fill your lungs. I hope that answers your question. I'll tell you what, let me continue on with the lesson. Good shout outs, good question. Okay, so we went through the troposphere where all life and all weather exists. The stratosphere where the commercial jets can fly if you have oxygen to breathe or a pressurized cabin. The mesosphere, remember, meteorites, mesosphere, meteors, mesosphere. That's where when you see one burning up, it's in the mesosphere. We've got just enough particles, they're dense enough to create enough friction for that grain of sand, that meteor, to create heat and burn up. We talked about the Kármán line, the definition of where outer space begins as we understand it. We'll talk about the ionosphere in a second. But that's all, the Kármán line, the ionosphere, this is all happening in the thermosphere. That's where things like the space shuttle used to orbit and where the International Space Station does sit in orbit. They're not using wings to fly, they're using velocity going around planet Earth. They've got enough velocity to balance it between their forward speed and gravity trying to pull them down, and they're able to orbit up there in what we call outer space. That's the International Space Station. That happens in the thermosphere. And here's something weird about the thermosphere. We call it the thermosphere. When you think of thermo, you think of a thermometer. I think of heat. So we talked about how the temperature drops in the mesosphere. In the thermosphere, the temperature actually rises. And by the time you get to the top of the thermosphere, what few particles there are up here at 440 miles above the Earth, what few particles there are can be, several thousand degrees in temperature, 3,000 degrees Fahrenheit. But there's so few particles that if you walked outside, it would feel cold because there aren't enough of those highly heated particles to bump into you and make you feel warm. It would still feel very, very cold because the atmosphere is so thin up there. That's the thermosphere. And then you get into what we call the very edge or the end of our atmosphere, and it's called the exosphere. Think of an exit. This is where these particles are no longer really held by gravity, and they can just wander on off, what there are of them, into open, free space. But it's at this level, and we're way up here at 6,000 miles plus the top of the exosphere. This is where some of our communication satellites orbit. This is also the area where the Hubble Space Telescope is located in orbit. Now, why do you think they might put the Hubble way up high in the exosphere, where there are very few, almost no particles? They put it up there so that it can get a very clean view of outer space without having to look through all those layers of particles that the atmosphere down here is blocking some of the light. So that's the exosphere. Now, we talked about the ionosphere and that special thing that happens. Have you ever heard of the aurora borealis, the northern lights? I just wanted to touch on this real quickly, since we're talking about layers of the atmosphere. There's another, I don't know if you would call it a layer, but it's a feature of planet Earth, and it's called the magnetosphere. And it's a layer of magnetic energy that reaches way, way out from the planet, thousands of miles out into outer space, tens of thousands of miles out. Those are all the purple lines that I was highlighting. And the magnetosphere does a great job of protecting planet Earth from what's called the solar wind. So when you see light coming in from the sun, those are particles and waves, and they're electrically charged particles. And sometimes there'll be a storm on the sun. We call those solar flares, a solar storm. You've heard of this before? Well, when those solar storms happen and they're pointed toward planet Earth, the planet gets bombarded with highly energized electronic particles. If they're super strong, they can be called an X-class solar flare. We categorize them by strength, and they can interfere with our satellite transmissions. But that's when it's really important to have a magnetosphere. It's a magnetic shield, and it protects us. It deflects a lot of that solar energy away from planet Earth so it doesn't do more damage to we and the living creatures down on the surface. But the magnetosphere is interesting. See how it bends down and actually is perpendicular to the Earth's surface at the higher latitudes? Here's a closer look at that. So again, the purple is that protective magnetic coating. And it actually becomes, where it touches the planet, and it becomes perpendicular or vertical up near the poles. That's these green lines we've drawn. Well, in that area where it becomes vertical, that's where you'll get the northern lights, the aurora borealis. Have you heard of this, or have you ever seen it? I've never seen it, but it's one of the things I really have to see while I'm here, is the aurora borealis, the northern lights. So what you'll get in the ionosphere, that's where you have enough particles, and it's called the ionosphere because in that layer of the atmosphere, it's very heavy in iron particles. And those iron particles, ever seen iron filings in a magnet? They stand up. Well, they absorb some of that energy from the sun, and they will glow in these eerie, beautiful curtains of light. They're very dim. You have to see it at night, but that's what causes the aurora borealis. Did you know that there was so much going on to the atmosphere? I always found this so interesting. Okay, in our atmosphere today, again, down in the troposphere, where all weather occurs, we've got moisture coming off the Pacific overhead. We've got a developing storm system out in California. That one eventually is going to bring us rain going into the coming weekend. And things have really warmed up here, and we've got a slight rain chance this afternoon and evening as well. Randy, do you have any more questions or shout-outs before we wrap up today's lesson?
Yeah, just a couple more. You got Penelope and Joaquin are watching,
Hey, Penelope. Hey, Joaquin.
as well as Jonathan, who is 10 years old in the 5th grade.
Hey, Jonathan. Oh, the 5th grade. The 5th grade is a great grade. Hey, Jonathan.
And Kaylee in 2nd grade.
Hello, Kaylee, 2nd grader. How you doing? Nice to see you.
Okay, and one other question. I can't recall if you got it, but Crystal wants to know, what is the ionosphere?
Okay, Crystal was asking about the ionosphere. And we can go over that one more time. The ionosphere is a very, very special part of the upper atmosphere, located within the thermosphere. That's the thermosphere, between 50 miles and 440 miles above your head. But within the thermosphere is this layer called the ionosphere. And it's called the ionosphere because of the high iron content of the particles in that part of the atmosphere. But as you might have learned, iron is can be a conductor of magnetic energy. And as we just mentioned, when we get these solar flares, these storms on the sun, and they shoot these highly charged electromagnetic particles at the Earth, they interact with the magnetosphere, but the magnetosphere absorbs that energy and it feeds it down into these little bands that are called the aurora oval. And that is where, at these higher latitudes on the planet, that is where the ionosphere, under the right conditions, will light up and create the northern lights, the aurora borealis. I hope that answered your question. All right, so we've got a chance for rain, a slight chance for rain this afternoon. There's a bigger storm system coming in toward the end of the week and this coming weekend. Do you have plans to get outside? We'll talk about the rain that's moving in. We'll talk about the rain we had last weekend. On the TV side, when I see you for the 411 at 4 o'clock on the TV side, we may have some press conferences. We'll definitely have a complete weather update on KHOU 11 News on TV at 5, 6, and 10. We will see you then. Thanks for joining me.